Hello everybody, welcome back to another Roblox tutorial. Today, I will be teaching you all about Vector3. Vector3 has many different uses, so yeah, it is something that's really important to understand. So yeah, let's get started with the tutorial. So Vector3 describes a vector in a three-dimensional space. Its uses in Roblox are positioning of the part, the physical location of the part, the physical size of the part, and also the rotation of the part, which is what I'm going to describe to you all in today's video. And most importantly, Vector3 stores three coordinate values: an x value, a y value, and a z value. So it's not just one value, it's three values. Okay? So the first aspect of Vector3 is position, which is its physical location. You may have seen my first episode where I mentioned, position property inside the properties window. As you see, CD part is at position 31.5. Let me just pop this down for you. So yeah, CD part is at x 31.5. Whoops, y 0.5 and z 9. That's its position. Position inside of Roblox, since Roblox is a three-dimensional game, Vector3 is used for positioning, size, and orientation / rotation. So, you have to understand it's three dimensions, an x, y, and z. Alright, so yeah, so what should I do next? So position uses Vector3. So let me just demonstrate how you can change the position inside of a script. So we're just going to go back to script 2 here. That's the script I created last episode. So I don't know, maybe we should, let's just don't mind anything that was in the that's here. That's something I've done in a previous episode. If you haven't seen my previous episode, make sure to go check it out. But anyway, so what should we do? So we should probably make a reference for this CD part. So let's just do like part equals workspace.cd part. Alright, so the way you change the position, the way you move a part to a specific position is if you write the part to the reference. So part.Position equals part.Position plus Vector3. That's Vector3 dot new. Whoops, not that example. What am I thinking? So forget about that. Part.Position equals Vector3.new. You notice that we are assigning a position. We don't have any position yet. We just got to put in the number. So let's say we just want to put it at a random location. All right. So I don't know. Let's say 50, 0.5, 27. Okay. So basically, it is assigning it the position. It's assigning the position. Part is assigning. Redoing its own position. So it's going to change its position. It's three values. It's basically changing its three values, and this is why we need a Vector3.new. That alone is the position value of the part. If we were to just use the things in the parentheses, it would just give you an error. This is why we have to do Vector3.new. Remember that. Alright? So I think maybe, let's just run it and see how it, let's run it. See how it works. Alright, so that was a split second there, but you may have seen the part. I think the part was somewhere around here, and it moved over here, and that was by the script that changed. That was by line 26 in script 2. You know what? Let's print part.Position. And if we're just printing part.Position, we can just do part.Position, and it's going to print out three values, as you see here. So on the output window here, it printed out 50, 0.5, 27. Alright, so that's its position. It's 3 position values. An x value, which is 50, a y value, which is like vertical up and down, which is 0.5, and the z value, which is at 27. Okay? So that's its physical location. So the next aspect we're going to be learning is size. Size is also a property that uses Vector3. So if you don't know, size, I've also included in my first episode that I've done on this channel. Size is basically its physical size. So its size, it has it's basically 3 dimensions, 3 size values. So depending on what direction it's at, so let's say, yes, so it's 4, so basically CD part is 4 studs, takes up 4 studs in the X, 1 stud in the Y, and 2 studs in the Z. It's like 4 by 1, it's 4 blocks long, 2 blocks wide, and 1 block tall. Alright? So that's its physical dimensions. Now, in order to change the part size, all we need to do is same thing as position. Part.Size equals Vector3.new. Let's say we want to increase the size. So let's just do 6, 3, I don't know, 8. Let's make it a big part. And maybe we should do 1.5. I'll describe how to position the how to position a part in the y direction, but this is what we have now. So we should expect the part to be much, much bigger. So let's just run it, and let's also print it. Let's also print out the size for you guys. So print part.Size. Actually, let me comment out this line so you guys better understand this. So let's see what part.Size is originally. Alright, so you may have noticed in the output window, size is 4, 1, 2. That's its size. It's 3 size values, 1 in the X, 1 in the Y, and 1 in the Z directions. And by the way, I comment out this line, so let's uncomment that. That line 30 is going to be active and change its size. So, oh yeah, as you see here, this size is much, much bigger. Instead of 4, 1, 2, it's 6, 3, 8. We changed that in the script, okay? So the final aspect is rotation or orientation. So orientation, if you don't know, is the rotation of the part. So let's say, alright, so let's see. Yep, orientation 0, 0, 0. I think the proper way to do this is to rotate in the Y. So if you don't know, green is Y. So as you see, its orientation, Y orientation is changing. But if we wanted to change its orientation, we would have to, level it up. So I think what we need to do, you know what? Let me just demonstrate this to you. So let me just here, let me just do like a wait 1 second. Let me just demonstrate this to you. First, I'm going to print part.Orientation. That's its rotation. And then we're going to change its orientation. So we're going to rotate the part 90 degrees. Let's see. I think we should rotate it positive 90 degrees. So same thing as position and size. So part.Orientation equals Vector3.new. It stores 3 values. Remember that. Vector3 stores 3 separate values, okay? So what should we do? Yeah, 0, 90, 0. So basically, to keep it on the ground, to keep it level, it would rotate in the Y direction. Let me just show you this, for example. So I'm just going to do... Oh wait, maybe we should put the wait beforehand, alright, afterhand, I mean. Alright, and then we're going to print part.Orientation, okay? And then, yes, so I think that should do. Alright, so as you see, you might not have noticed, but there are two. So you see, this is the original orientation of the part, 0, 0, 0. It wasn't rotated at all. And then the second print printed out 0, 90, 0. The X and Z rotation didn't change. However, the Y value changed. It set itself to 90. So if you don't want to change, if you just want to keep the values the same, what am I saying? If you want to keep the values the same, you just write 0 inside of those slots. Okay? Let me just explain briefly, real quick, why the Y position matters. So basically, if you don't know, the exact position of a part is relative to the very center of the part. Now, I don't know how to demonstrate it right now, but let's say if you had a translucent part and you put a little teeny tiny dot at the center, that's where its position would be. So at the very center of a three-dimensional part. So let's say the part's height is 1. The center would be at its real position would be 0.5 in the Y direction. And if it were to be 3 studs high, it would be at 1.5. So basically, if you want to calculate the Y position, take its height and divide it by 2. Remember that. Take its height and divide it by 2, and you would get its you would get its Y position value. Okay, so let's say you wanted to change. Let's say you wanted to change the Vector3 values relative to its existing Vector3 values. So I'm going to change this. So originally the CD parts position is at 31.5, 0.5, and 9. So if we just want to move it one stud without having to know what exact position it is, we can, so let's say if we just want to move it one stud from where it is, 1 or 2 or 5 studs where it is already now, here's how you would do it. So do part.Position equals part.Position plus Vector3.new. So basically, this is arithmetic. This is basically taking its own position and adding it, well, what am I saying? It's adding its own position by whatever numbers you put inside the parentheses. So let's say we wanted to change its X value. If we want to move it 5 studs in the positive X direction, yeah, positive X direction would work fine. Yeah, let's just get rid of the, I don't know. I'm going to get rid of these, so just not to bother you. Alright, so let's just do like a wait 1 second or wait 5 seconds. So that's going to be a bit of a delay. So if we want to move it 5 studs in the X direction, all we would need to do is 5, 0, 0. Remember, the first number is the X value, the second number is the Y value, and the third number is the Z value. So if we want to move it 5 studs in the X direction, we would put 5 in the first slot. If we were to move it 5 studs up, we would put in the middle one. If we were to move it 5 studs in the Z direction, we would put 5 inside of the last slot. Okay? So I'm just going to print parts position real quick, just to, print part.Position. Alright, let's see how this works now. Alright, so it should wait 5 seconds, so, ooh, yeah, there we go. Okay, so I think what happened was, hold on, maybe I should comment out these two. Alright, so I do not want the other ones to get in the way, so we just have to wait a few seconds, and, oh yeah, so as you see, it moved 5 it moved 5 studs. So basically what it did, it moved 5 studs away from its original position, from its existing position. So originally it was at 31.5, and now it's at 36.5. It's basically the same principle. It's basically the same thing as adding it in the z direction. So what's its position in the z? 9. So let's just see how it's at like 9. Alright, so originally it was its z position was at 9, now it's at 14. So basically that's how you add its own existing position. Like I said before, if you want to assign it a specific position in the grid, all you need to do is do part.Position equals Vector3.new and whatever position you want. If you want to add its existing position, if you want to take its existing position and let's say move it a few studs away from its existing position, you would add you would put part.Position equals part.Position plus Vector3.new. So that's just one extra thing. You would put the part.Position when adding its own position, but you wouldn't when you're just assigning its own position. Same principle with doing it if you want to add its size. So let's say you want to add its size you would do part.Size equals part.Size plus Vector3.new, blah blah blah, and part.Orientation equals part.Orientation plus Vector3.new. You get the concept. So it'd be great if you guys practice this on your own. But this is the end of the video. Hopefully this was helpful for you. If you like this video, subscribe to the channel. Stick around for more content. I'll be posting another video pretty soon. I'm just not sure on what. And I'll see you later. Bye.